So now we're going to take a look at specific heat. And we're going to add some calculations into what we've been learning in terms of heat. And so here we have our phase change graph that we're going to work a lot with this year. But here's our equation. So Q, and here's all what our variables stand for. Q stands for heat. The symbol, lowercase q, is the symbol in chemistry that we use for heat. M stands for mass of whatever substance we have. T stands for the change in temperature, and C stands for the specific heat capacity. Now, specific heat capacity is how much energy it takes for a certain substance to change 1 degree Celsius. So how much certain things take a little bit of heat to change 1 degree Celsius. Certain metals have a pretty low heat capacity, meaning they heat up quickly. And then some things have a high heat capacity. Water is known to have a higher heat capacity because it takes 4 joules of energy to change 1 gram of water 1 degree Celsius. Okay, so the specific heat capacity is joules per gram degree Celsius. How many joules does it take to raise something, 1 gram of something, by 1 degree Celsius? And so when we're looking at problems like this, we have different heat capacities for different substances. So if we're looking at A and we're looking at a change in temperature, the specific heat capacity, which is also CP in many things. There's 2 different symbols that are pretty common for heat capacity. So it's C or CP, and I'll use them interchangeably. It's sort of like molar mass and gram formula weight are the same thing. So I want you to be exposed to both, because depending on where you see chemistry, you'll see it both ways. So the heat capacity of ice, it takes 2 joules of energy to take 1 gram of ice and make it go up 1 degree Celsius. Like I mentioned, water has a fairly high heat capacity because of it being polar. So it takes 4 joules of energy to take 1 gram of water and make it go 1 degree Celsius. And then the heat capacity of water vapor, it takes 2 joules of energy to make 1 gram of water vapor go up 1 degree Celsius. So A, C, and E, A is referring to if we have a problem in this range, that's the value we use. If we have a problem with water, that's the constant we use. And if we have a problem with steam, that's the constant that we're going to use. So taking a look at a problem, how much heat is required to change 10 grams of water from 20 degrees Celsius to 50 degrees Celsius? So the key thing that we're seeing here is water, okay? And those constants that were on the previous page, I will always provide you with those. You don't need to ever memorize any of those constants, although I'm sure that you will learn 4.184 because we will use water's constant over and over and over and over and over again this unit. So my equation is MC delta T, so MC, change in T. And one of the ways to remember it, you do need to learn the equation, is it sort of looks like MCAT. I know that's not an A, but sometimes it looks like CAT a little bit. And so we just go ahead and substitute the things in. So my mass is 10 grams. My constant, because it is water, is the 4.184. And then my change in temperature is 50 minus 20. I always make my changes in temperatures positive. We're going to learn about putting signs in on heat to make it negative or positive. And I just do that at the end. To me, that makes the most sense. So 10, 4.184, and then 50 minus 20 is 30. So the amount of heat that is needed is 1255.35 joules, which really, when you get down to significant figures, is 1,260 joules of energy. That's how much it would take to change 10 grams of water from 20 to 50. Taking a look at another problem, how much heat is required to change 10 grams of ice from negative 30 to negative 10. Again, we have our same equation, but notice that in this time we're using ice. And so we fill in that 10 grams, we fill in our new constant for ice, which is 2.03, and then we do our change in temperature, okay? And it is the absolute value of the change in temperature. We're not going to have a negative. You're just looking for the absolute difference between the two numbers. So I don't want you to get too bogged down with the negative signs. Our changes in temperature are always sort of the absolute difference between the two. So 10 times 2.03 times the 20, and the amount of heat required to raise 10 grams of ice 20 degrees is only 410 joules. So this is our first type of problem, and we're gonna do many different types of problems in many labs this unit. They all seem rather similar, so I want you to start compartmentalizing what things are important in order to know when to use this equation. The most important thing is that it's a change in temperature, that you're dealing with parts where the temperature is changing. I just want to flip back to the graph that we have here. We're looking at these phases of the graph where there's a temperature change. Remember, when we're going from freezing or boiling, is that all those particles have to change from a liquid to a gas, but there is no temperature change. We cannot use this equation for these parts of the graph, and that's an important thing, distinguish between the types of problems. So I'm pointing that out now because we're going to manipulate and use this equation many different ways, and the heat equations, obviously this one's pretty simple, and they are all pretty simple, but you need to start to identify what equation you need to use with what type of problem. That will be the hardest part of the test. So the important thing here is that it's a mass of something, a specific heat capacity, which is fairly consistent, but something is changing temperature. So that's the one thing I want to point out to you.